Hello good people, I'm going to talk about how to calculate areas of various polygons. I will start with a humble rectangle. To calculate its area, we need the length and the width. And so the formula is length multiplied by width. I could have also said that length is the same as the base of the rectangle and the width is the same as its height. And correspondingly, its formula would then be base multiplied by height. The letters we choose to use in these formulas do not really matter that much, but they do help when it comes to communicating our ideas across. In case of a square, the length and the width are of same magnitude, and so the formula here could be length multiplied by length, or simply length squared. Once again, instead of using the word length, I could have talked about the base, and so the formula would then be base squared. Note that every time we calculate an area, we are going to have two dimensions that are being multiplied by each other, such as length multiplied by width or base multiplied by height. The same is true for the parallelogram. We need the length or the base of the parallelogram as well as its height, and so the formula will be base multiplied by height. The formula for calculating the area of a triangle is very similar. We need the base of the triangle and its height. And so the formula is base multiplied by height divided by 2. Why are we dividing by 2? This is because each triangle is in effect half of a parallelogram, or half of a square, or half of a rectangle. And so we have base multiplied by height divided by 2. In case of a trapezium, things get interesting. The formula is a plus b in brackets multiplied by height divided by 2. Letters A and B represent the lengths of the parallel sides of the trapezium. Where does the divided by 2 come from? Let me add in another trapezium that is identical to this blue one. This trapezium also has two parallel sides. The shorter one that I'm going to label A and the longer one that I'm going to label B. These two identical trapeziums form a parallelogram, and the area for a parallelogram is base times height. We have the height. The base would be these two sides combined, a plus b. And hence in the formula, we have a plus b multiplied by height, and then because we only want half of this parallelogram, we divide by 2. Alright, let me explore polygons with 5 or more sides. I'm going to use a regular pentagon and hexagon as my examples. Each regular polygon can be divided into congruent triangles. And so if we can calculate the area of a single triangle, we would be in a position to calculate the area of the entire polygon. I'm going to work on the formulas for these two shapes simultaneously. In each case, we need the base of the triangle and its height. So we will have base multiplied by height divided by 2, because that is the formula for a triangle. In case of a pentagon, there are 5 triangles, and in case of a hexagon, there are 6 triangles. So I'm going to multiply by those numbers respectively. The number of triangles also corresponds to the number of sides in our polygon. And so we could create a general formula for any regular polygon. And it would be number of sides multiplied by base multiplied by the height divided by 2. This formula is often expressed somewhat differently. Instead of the height of the small triangles, we talk about the epithem. The epithem is a line from the center of a regular polygon to the midpoint of a side. This means that the general formula for any regular polygon with 5 or more sides can be expressed as number of sides multiplied by the base multiplied by the epithem divided by 2. I appreciate that these formulas may look different, but behind each of them are 2 dimensions. Sometimes we have to do a few other things, but ultimately it comes down to the base and the height. Or as my great aunt used to say, it's all about girth and length. Needless to say, neither me nor my cousins were allowed too many mathematics lessons from her. That is all for now, and I will see you on the flip side.